So do you want to introduce yourself and talk about your poster a little bit?
Sure.
Oh, you can hold it as well.
Sure. My name is Thaddeus Brink. I'm part of the Research and Core Technology group at Medtronic, in this case supporting the pelvic health and gastric therapies area. We've got two pieces here. One around physiology of sacral neuromodulation, which is a clinically approved therapy for urinary and fecal incontinence. Our focus here on the bladder side. And then secondly, a technology piece and thinking about research systems. So very, very briefly, InterStim therapy, sacral neuromodulation, is a continuously given therapy that increases bladder capacity. But interestingly, it's not a continuous system. There are long storage phases before the void. And what we've done in a variety of studies, both in anesthetized rodents as well as in a fully conscious sheep model, is using urodynamics, which is used clinically. So what we find is we see increases in bladder capacity when the therapy is given or applied non-continuously, but only when it's applied in the latter phases of bladder filling. So if you apply neuromodulation in the first half or any of the first 3 quartiles of the fill cycle, there's no significant effect on bladder capacity, whereas if you apply it in the second half or the 4th quartile, you get increases in bladder capacity that are equivalent to continuous. And we've shown that in the anesthetized rodent as well as in the sheep. Now, there's an interesting thing. In the DBS space, they have the ability with the RC plus S device or the Activa PC plus S device, or PC plus S device, to be able to sense and to stimulate on 4 contacts. And what you're doing is stimulating on 2 and recording from 2, and you're recording a signal that is a biomarker right there at the local site. But in the case of sacral neuromodulation, you're actually stimulating at a nerve that is far away from where you're trying to pick up that physiological signal. And so what we're using with the Summit RC plus S system is the ability to bring in an external sensor. And so we have a commercial off-the-shelf sensor that records bladder pressure. And when we see a void, it then sends a signal through an API to the device to then shut off stimulation for a period of time and then turn it back on. So instead of this local sensing to modulate when therapy's on and off, we're now using a completely external sensor to be able to do that. And so this was a nice kind of confluence of both a physiological as well as a technological way of thinking about dynamic stimulation in the sacral neuromodulation space.
Very cool. Yeah, this is very interesting stuff. So what were some challenges with this? Yeah,
so there's a couple of pieces that have been interesting. One was thinking about a large animal model. So most of the work in the sacral neuromodulation space has typically been done in anesthetized preps. So you're looking at very short periods of time, and usually done in rodents, maybe in cats.
And why sheep in this case?
Yes, so we looked at a variety of large animal models. One, just to be able to get to human-sized and human-grade clinical devices to be able to test new technological capabilities. But we looked at dogs, pigs, and sheep. And one of the interesting things is that these sheep have the same kind of opening sacral foramen that humans do. Dogs and pigs actually have closed off foramen, so you can't do the same clinical procedure for the implantation that's done in humans. Also, these animals are very well kind of amenable to behavioral kinds of experiments. We can have them in a situation to do urodynamics for a couple of hours. They don't try to run away on you. So they're actually great animals to work with. But we're able to do these things in fully conscious animals.
And was it more difficult to get approval, like IACUC approval to do sheep?
So what's nice is that within Medtronic, where we have a long history of human-sized devices and needs for long-term safety data in terms of fixation and migration, our IACUC is well used to understanding these kinds of experiments. Some of the behavioral kinds of experiments were specific to the bladder side, but no, the IACUC is very well versed in kind of these kinds of experiments.
Okay, very cool. And maybe what are some following directions? Where are you guys going to be taking this?
Yep, so we have things we want to understand further, refining both the kind of physiological timing as well as working with the API to make sure that the signal coming out is very well timed, only detecting voids and not something else, and then really working on the timing of how stimulation is applied.
Okay, excellent. Thank you so much.